Okay, now many of you are not going to agree with me on this talk, but this is based on my consulting assignments, my coaching assignments with a lot of automotive companies and what I have heard from the ground. So if you have brickbats, wait till the talk is over, we can meet outside, not on the stage, okay? One of the most regulated industry, the highest regulated industry I've seen is casino gaming. After that, medical devices. Then comes automotive. Safety, A-Spice, AutoSAR, 26262. But still, failures happen. Now, failures will happen. That is normal. Now, if you really get into why failures happen, other than the normal root causes that we do, I come to this Upanishadic verse. It says, Yada Pinda Tada Brahmanda. As is the microcosm, so is the macrocosm. So there is something going wrong at the microcosm level. Your platform architecture, your overall compliance, everything is great. But something is going wrong at a component level. And when I say component, I don't mean individual components that you put in. I'll come to what I mean as a component out here. Now you have this discussion with many architects. I've met many architects and they get into this high level design, low level design, models versus implementation aspects. And what I mean by a component is when I'm building my system architecture, there are individual units, subcomponents, etc. And many people will say that is low level design. I leave it as a black box. I really have nothing to do with it. And the often given reason for that is, JP, haven't you heard? Architecture is design, but all design is not architecture. That is design. For something to be called architecture, a change has to be costly. It has to be risky. There has to be an impact. That subcomponent out there, that small component out there, I don't see a change out there to be very, very costly. So for me, that is just design solutions. It's not architecture solutions. I am leaving the space to the developer or the module lead. So what we see, and I use this term disproportionate very, very responsibly. Very responsibly. I see a lot of disproportionate amount of time, energy, effort being spent towards creating great platform level architecture. Wonderful central design paradigms. Lot of time spent on creating high level models, but the component level architecture, and here also I use the term architecture very, very responsibly. I'm not talking about design. I'm saying component level architecture, because there are some important decisions to be taken at component level also, which it is not the architect to be, it's not for the architect to take. It is for the component lead and the module lead and the senior developer to take, but that is also architecture, and I see that's left to teams. And sometimes what should have been very thought out, trade-off, analyzed design just degenerates into simple design. So some of the things that I have seen at component level going wrong, I have to rush through this talk because there is a lack of time. So what I see, one, sloppy delegation. Delegating parts of feature, functionality, quality requirements which a component should have handled at multiple places. Or I see a lot of Lego syndrome. Now, many component leads will start thinking, oh, I need to design for the future. I need to design for reusability. And what happens at that level? Every small bit of task responsibility, like a Lego block, gets separated out, when it should not be separated out, and nobody is really looking at those kind of implementations. You have scattered parasitic functionality, you have functionality scattered across multiple components. On the other end, people sometimes do concert overload. doing too many concerns, too many tasks within the same component where there is absolutely no separation of concerns. Okay, and I'll come to why this is happening. Some leads, some component leads, some senior leads, etc., they want to prove they are Rambos, they are commandos, they are NSG commandos. So every component they build is a Swiss Army knife. It tries to do everything. No, because tomorrow we might need it. Or this kind of extension is coming up. Or this interface also might be required. Usually, when you want to build a good system, my definition of a good system is perfection is achieved not when you have nothing more to add. Rather, perfection is achieved when you have nothing more to remove away from something. But unfortunately, that's not what people try to do. And then finally, the easiest method out, architecture by implication. This is what the company does. Everybody is doing layered architecture. I am also going to layer my components. Some high-level person has decided this is how things should be. No innovation, no thinking, just implementing and inheriting those components. On the other end, we have people who think design principles, understanding all the gang of four patterns and trying to mix them all together is going to solve their problems. Okay. Now, we have each person out there, including your junior developer, need to understand good design principles. I always say there is TDD, test-driven development, there is BDD, behavior-driven development, but the most common form of development that I have seen implemented is GDD, Google-driven development, where there is no thought process that is going in. There is absolutely no thought process that is going in. Somebody has done a component this way, or somebody on the net or Stack Overflow has done this way. No thinking, no design principle implementation, just implement. On the other end, some people go and say, I want to do this, I want to apply the layered pattern, I want to do this pattern, I want to bring in a lot of other patterns, everything that I have learned from the textbook I want to implement. The truth is somewhere in between. I bought in this particular example very, after a lot of thought, thinking why should I think about it. So there was this it's a client I was consulting for, and then when I was looking at some component, I said, see, if component A calls component B, it's a one-way call, it's loose coupling. But if there is a reverse call coming, that becomes a cyclical dependency. So moment there is cyclical dependency, theory tells us that is a form of tight coupling. Now this was the theory that is saying. Then immediately that person came to me and said, you know what, I have this component which has to call this component, and acknowledgement is necessary. But moment I get the acknowledgement, I'm getting into cyclical dependency. Should I implement it? Let me try to split them up. I said, see, theory, you are not paid to follow the rules. You are not paid to implement design principles and patterns as you have studied in the textbook. For that, I need probably somebody who can just read through the thing, and with Gen AI and all coming, they can do it better. You are paid to understand that particular context. So what if it is tight coupling? Under which IPC section can you be tried and put in jail if there is one component which is got tightly coupled? Don't make it a habit. Know the consequence of breaking a rule. That should be taught to people, that there is a consequence. These principles have been taught to us that there is a consequence. But that doesn't mean you are paid to follow the rules. You are paid to come out with a solution. And for that, we need to start thinking of our component leads, module leads, no more as designers and developers. We need to start off thinking of them as component architects. We have to, the same things that we do at a platform architecture level, we need to make them aware and implement some of them. For example, they need to understand every design and every architecture is a trade-off. There are no free lunches in the world. You can't achieve this and this. There is a trade-off. And without that trade-off, there is no system built. They need to understand that trade-off and why that trade-off is taken. And sometimes they should have the guts to go back to the architect and give a feedback saying that you know, the implementation that you have suggested, I have a better way of doing it. That backward feedback should be accepted. They can keep the central architectural paradigms intact and still innovate. I have seen people do that. Without breaking the overall rules and the structure, they can still innovate. You should give them that space. Of course, they should need to understand the design principles, etc. And the most important thing, according to me, is we should teach them to document their decisions. If they are going to take a trade-off or they decide, okay, this is how this communication is going to be done. I am going to split this interface into 3 more interfaces. Why? What were the alternatives that you considered? Why did you reject that alternative? Only then their thinking will also start looking at what other possibilities are there. And like we create architectural decision records, it's very, very important that at component level also, at least the important costly decisions, we get them into this habit. And then they will evolve. Those will be the people who will do system architecture and great system architecture for you in the future. Okay. Now comes the promotional part, which I am supposed to do. Okay. Everything ends. See, I told you there are no free lunches. I spoke for 10 minutes now. So I also teach some of these principles, but this is primarily not for that. I also teach some of these principles with the International Software Accreditations Board's Software Architect program, where we have seen that many of the people who have attended it, including senior architects to module leads to senior developers, etc., sometimes come out or understand and appreciate some of these solutions better. So iSAQB is a non-profit organization, is an international organization, is the most recognized certification in the industry today for software architecture, including you have the foundation level and of course at advanced level, you know, agile architecture, domain-driven design, functional architecture, embedded architecture, many of these things are covered. I think I have kept my time. Thank you so much. I'm sure there are no questions. Sure.
How do you compare this with the aviation standards or aerospace standards? You compared this?
Unfortunately, sir, I have not worked on it, so I might not be the right person. With all,
I will be stepping into points.
sure, please give the mic. I said I'm going to get bashed. Please.
So in the
It's not on.
I think, first of all, I like the architecture up to the component level, but in the aerospace industry, it goes further down. Component source.
Okay.
Track from the raw material to the component level, which comes into the designer's hand, then forward and backward loop until the top architecture is achieved.
Wonderful.
And the second thing is, we are in
So this is DO 178B, is it?
Yes, DO 178.
Yeah.
So what happens is, like, we think all this flow from the requirements and the target, and we have a parallel V's which runs into at the architecture level, hardware and software, unless all these architecture requirement flows to the component level, the loop is not closed.
Wonderful, sir.
That's why it takes more time. Of course, in DO 178 also, we have different levels, A, B, C and all. So they consider that there is they don't neglect anything.
Okay.
Okay, that's what I want to say.
That's great. In spite of all of this, Boeing MCAS happens also.
Yes, because somebody has not
Not followed it.
followed and
Followed
connected
it. Yeah.
top to bottom.
Yes. Thank you, sir. Thank you so much.